Hello, my name is Rob Reynolds. Welcome to Mat-073, Chapter 2, which we're looking at Section 3, finding the domain and range of functions. Remember, the domain are my x values going left to right. The range are the y values, and I like to call them bottom to top. And the reason why I'm going bottom to top is because when I list the range, I might put in an interval notation. So it might go from like 2 to infinity. I just want to make sure I put the lower number on the left. So the range are your y values. Your domains are going left to right. But notice that the lower is on the left. Range is bottom to top. Put the lower number on the left. So remember, any set of ordered pairs is called a relation. But if it's a special relation such that for every x there's only one y, then it's called a function. So we're going to look at the domain and the range of both functions and relations. So first of all, this is a function because it passes the vertical line test. You can look at the previous video, section 2.2, talking about the vertical line test. But this says state the domain, which are the x values. So I'm going to go through and say, okay, well the x value here is a 1. So the domain would, because this point is 1, 0. So I'm going to state that the domain could be a 1. The domain could be a 3. The domain could be a 4. And it looks like the domain also could be a -5. So I'd probably put those in order. I should have gone from left to right. So maybe -5, 1, 3, and 4, putting the lower number on the left. Let's do the same thing with the range. But let's start at the bottom. So the bottom, the y values is what I'm looking for this time. So maybe -5 for the y value. Looks like a 0 and a 1. For the y value, and this y value is a 3 that lines up with this point. So the domain are the x values. You could just go ahead and just state all the points and then just read off the there's your x, there's your y. So if you wanted just to name all these points, this is 4, 3. All of your x's, so this 4 is this 4, and this 1 is an x value, is this 1, and we could do the same thing. This 0 here is this 0, and this 3 here is a y value, and it appeared here. So I could name the other points that just keep picking off x's and y's. But it looks like the domain and the range we got correct by putting them the lower number on the left, the lower number on the left. Moving on, what is the member of the range whose is paired with -2. So we're finding the y value, and this must be x equals -2. So I'm going to go to my x is -2 and find this y value, and it looks like a 3. So I would say 3 is the answer for A. For B, it says what's the domain of the function, and the domain goes left to right. So it looks like the farthest left is -5, and it includes -5, and the farthest right that it goes is a 3. So I would say, from -5 to 3, and I'm going to put a bracket on there because it looks like those are closed dots. If this would have been an open dot here, then I would put a parentheses to say that it doesn't include the 3. But since it's closed, then I'll put a bracket. Okay, the next part says what's the member of the domain. So give the x value that's paired with a y value of a 6. So I'm going to look for the y value of a 6, which is here. And then try, this doesn't look like it's exactly on the line. So maybe, I don't know, 2.2, 2.5, 2.3. A little bit hard to see. We'll see what the author says in just a moment. But they're asking for the x value given that it's paired with the y value of 6. And then what's the range? And of course the range is going to be bottom, the lowest value. It looks like it's a 1. All the way up to the highest value. So the range would be bottom to top. Remember your y values. So the lowest, putting the lower number on the left, would be -1 all the way up to, it looks like 7. I can include the -1 because it looks like that's actually a closed dot there, and 7 is also a closed dot, so I'll put brackets on all these. I'm interested in this 2.3. I wonder what the author said. Maybe so we got the correct answer for number or letter A, which is a 3. The output is a 3. B, we said, yep, we put it in interval notation, -5, including -5. That's what this line says here. up to 3. I like interval notation. This is inequality notation. There it is, 2.5. We guessed 2.3. I didn't think that was quite in the middle, but that's pretty close. And then from -1 to 7, I think we got that. And I like this box because that's showing you the lowest to the highest point. So finding the domain means all the acceptable x values that this could be. So because remember, the domain goes left to right. So anytime that I run across something that x cannot be, then I'll kick that out of the domain. So notice there's two big things that you don't want to do. You don't want to take the square root of a negative number because that's imaginary. And we don't want to divide by 0. So those are the two things right now that you know of that are big no-nos in math, taking square roots of negatives and dividing by zeros. Later on, we're going to be learning that the log function, you don't also want to take the log of a negative. So there's other things that cause the domain havoc. But for now, we're going to be looking for these two things, A and B. And maybe in this lesson, maybe we're just really concerned with B. We don't want to divide by 0. So I'm really interested in when does this x minus 8 equal 0, because when it does, then I'm going to be dividing by 0, and that's a big no-no. So if I add 8 to both sides, x equals 8, but that's what I can't let the domain be. So I'm okay to let x be anything but 8. So from -infinity all the way up to 8, but I can't include the 8, and by the way, you never can include infinity, in union with from 8 to infinity. So this is one way to write the domain. Another way to write the domain would be the all real symbol. It kind of looks like the paragraph sign, and you would just say x can't be 8. So either method would be good for me. It looks like they did x such that x is a real number and it can't be 8. So I kind of like these two methods a little bit better, method A and method B. But if you want to use method C, you certainly can. I don't think many students are real comfortable with that notation. But find the domain and the range. So let's go for the domain first of all. Finding the domain of this thing says how far left does it go, and I think it goes forever to the left. I know it's going down, but it's also going to the left forever and to the right forever as well. So I would say again, it's all reals. If you wanted to write that from -infinity to infinity, that would be fine as well. The range is bottom to top, so the lowest that it goes is probably -infinity. It goes forever down. But the highest that it goes is probably a 2. So putting the lower number on the left, I'll start with -infinity, and then I'll go all the way up to 2. The question is that a closed dot or an open dot? And it looks like that's actually a value, so I'm going to put a bracket there. Let's see what the author says. Yep, they just said all reals. Again, if you wanted to use that symbol for all reals, you can. And then the range, they did use interval notation from -infinity, and notice that they do have a nice bracket here to include the 2. The domain here, the x values would be, again, all reals because it goes forever to the left and forever to the right. The range, the y values, I think is also going forever down and forever up. So I would also say all reals. So it looks like all reals is definitely a should be for all lines. Any type of a line, domain and range, I think is going to be the same. We've talked about this function a couple times. It's the absolute value function. Some of you remember values start with the letter V, and so that's actually what the graph is going to look like. It may not be at the origin, but it does graph a V somewhere. It may be here, but it may be here. It doesn't matter where it's located. It might even be pointing down. But the domain, now the range is not all reals, but the domain says how far to the left and how far to the right. And I think all of these, all three examples go forever. So I would say the domain is all reals, because there's nothing that would cause the x to divide by 0 or take the square root of a negative, which is basically the only two things that would kick out the domain right now. So looking again, I don't want to divide the denominator by 0, so that's going to cause havoc. So I don't want to do 3 divided by 0. So let's go find out, when does 2x minus 5 equal 0, because that will cause me to divide by 0. So 2x is equal to 5 when x equals 5 halves. So remember, I don't want x to be 5 halves, because that's when, if I plug a 5 halves in here, I'm going to take 3 and divide by 0, and that's a big no-no. That's always undefined. So I'm going to kick that out of the domain by saying, well, it can go from negative infinity up to the 5 halves, but I don't want to include the 5 halves, and you can never include infinity, in union with 5 halves up to infinity. Again, if you would like to do a shortcut method, I don't mind saying that the domain is all reals. You just don't want to let x be 5 halves. This is good notation. Recognize all forms here. So there's form A, form B, and then they might put it into this form, x such that x is, this is set builder notation, x such that x is a real number and x cannot be negative 5. But I kind of prefer this method, interval notation. That's what we'll be using for future examples too. I hope this video was helpful. If you have questions, feel free to email me.